All right, so moving on to section 4.2, direction fields and numerical methods. Numerical, here's that magical word again. Remember, numerical means that I'm wanting to do the calculus stuff without actually having to use the calculus skills, right? Trying to find like an easier way out, okay? So first, let's define what a direction field is. These are also called slope fields. I actually think I use slope field more than I use direction field, but it doesn't matter. They mean the same thing. But what it is a mathematical object used to graphically represent solutions to a first order differential equation. Remember, first, what this means is that I just have y prime. I don't have y 2 prime, y 3 prime, or any of that, just y prime, okay? At each point in a direction field, a line segment appears whose slope is equal to the slope of a solution to the differential equation passing through that point. So basically what it is I'm going to draw a plane like I have right here, right? And at every point, I'm going to plug that point into the equation because that's going to tell me what the slope is. Remember in Calculus 1, we learned that the derivative gives me the slope at that point. So if I plug a point on here into y prime, that's going to give me the slope at that point. So at every point, I'm going to find what the slope is and then draw a line with that slope, okay? Let me show you what I mean. What I will say is that the actual process of this isn't very hard. It's just gonna take a while because it's a lot of points. And so it's not hard, but it's just a lot you are gonna write down. Example 1, create a slope field for the differential equation y prime equals 3x plus 2y minus 4 and sketch a solution curve passing through the point 0, 1. So we're going to draw a slope field. So on the note sheet for everybody that's in my class, I give you a plane that's pretty big, right? This is a lot of points because you're going to have to sit there and go through every single point and draw one. I would never ask you to draw one that big, ever, ever, ever. Now, for people not in my class, your teacher may, but I won't. So what I'm going to say is let's just do a slope field going from -2 to +2 on the x and the y. That's it. I only want one that's that big. Anything past that is insane. So, okay, so the differential equation is y prime equals 3x plus 2y minus 4. And again, y prime tells me my slope. So I'm going to go through every point on here and figure out what the slope is, okay? So my first point is -2, 2. That's right here. So I'm going to plug in that first. So the first point is going to be -2, 2. In that case, y prime would be 3 times -2 plus 2 times 2 minus 4. That's going to give me -6 plus 4 minus 4, which is -6. So at -2, 2, my slope is going to be -6. So draw a line segment there with the slope of -6. Now move on. Next one is -1, 2. So for -1, 2, do the same thing. Y prime equals 3 times -1 plus 2 times 2 minus 4. That's going to be -3 plus 4 minus 4, which is -3. So at that point, draw a line segment with the slope of -3. If it's not perfectly right, that's okay. Mainly as long as you know if it points down or up or straight. That's what I really want to know. But yeah. My next point, 0, 2. So y prime equals 3 times 0 plus 2 times 2 minus 4. That's 0 plus 4 minus 4, which is 0. Slope of 0 means it's a straight line. Next point is 1, 2. Y prime equals 3 times 1 plus 2 times 2 minus 4. That's 3 plus 4 minus 4, which is 3. So my slope there is 3, so draw a line segment with the slope of 3. And then I have 2, 2. Prime equals 3 times 2 plus 2 times 2 minus 4. That's 6 plus 4 minus 4, which is 6. So draw a line segment there with the slope of 6. Again, I really only care about pointing up, straight, or down. You're going to do that for every single point in here. So this would be negative 2, 1, negative 1, 1, 0, 1, 1, 1, 2, 1. Then do every point on here. Negative 2, 0, negative 1, 0, 0, 0, 1, 0, 2, 0. Then again right here. Negative 2, negative 1, negative 1, negative 1, 0, negative 1, 1, negative 1, 2, negative 1. Then do it again down here. Negative 2, negative 2, negative 1, negative 2, 0, negative 2, 1, negative 2, 2, negative 2. Do that for every point, and it's going to give you a slope field. I want to pause, draw this out because it would take me a very long time to write it out, and I'd have to erase and everything, and it would waste a lot of time on here. This is what I do for every point. Do exactly this. Okay, so after working them all out, you should get something like this. The only straight ones are going to be at 0, 2, and then at 2 to negative 1. Everything else will either point down or up. So this is a slope field. Now you may be thinking, what does this do? Why do I care about this at all? Here's why. The second part of this asks you to draw a curve passing through the point 0, 1. So what this means is I can start at the point 0, 1 and follow my lines, and it's going to give me an approximate curve. So this is the approximate graph for y. That's why I care about this. So this is a way, again, of us being able to find the y. This should be a y. That looks really bad. Y didn't help. Anyway, this helps us find the y without having to use the calculus stuff, right? So it's like an easier way to find my y. So let's do it again for example number 2. Create a slope field for the differential equation y prime equals x squared minus y squared, and sketch a solution curve passing through the point negative 1, 2. So for this one, again, I'm going to draw a slope curve or a slope field. So 2 back, 2 forward, 2 up, 2 down. And this time the equation is y prime equals x squared minus y squared. So again, let's do this. I will show you the first row. After that, you should be able to do them. This first point, negative 2, 2. So y prime there is going to be negative 2 squared minus 2 squared. Negative 2 squared is 4, minus 2 squared is 4, so 0. This is a straight line. Next point is negative 1, 2. Y prime is going to be negative 1 squared minus 2 squared. Sorry, brain lapse for a second. Negative 1 squared is 1, minus 2 squared is 4, so negative 3. So that line's pointing down. 0, 2. Y prime equals 0 squared minus 2 squared. That's 0 minus 4, which is negative 4. So pointing down. Next point is 1, 2. Y prime equals 1 squared minus 2 squared, which is 1 minus 4, which is again negative 3. So that's also pointing down. This point is 2, 2. Y prime equals 2 squared minus 2 squared. 4 minus 4, so 0. This is also a straight line. So this should be straight, then pointing down, pointing down, pointing down, and then straight. Do that for every point inside of here. Okay, and you should have something like this. It should be straight here. It should be straight here. It should be straight at this one point, then at these 2 points, and then at these points, and then everywhere else either up or down. So again, why is this helpful? If I want to pass through the point negative 1, 2, I can start there. Negative 1, 2 starts right here and follow this curve. How neat is that? Now that is going to be the approximate graph of our y. Okay, so another way I can use these slope fields is for finding something called equilibrium solutions. So let's look at that. The definition is right here. Consider the differential equation y prime is equal to some function of x and y. An equilibrium solution is any solution to the differential equation of the form y equals c, where c is a constant. So the equilibrium solutions are everything where y is equal to a constant. Okay, so like going back to our handout for section 4.1, none of these are, because I have x squared, then I have e to the minus 3x, 3e to the x, so none of these are constant, right? A constant would be like y equals 2 or y is equal to negative 1 or that kind of thing, right? A constant. So if y is equal to a constant, what do you think y prime is? If you think about that a little bit, I'm going to pause to give you time to think about it. If y is a constant, what would y prime be? Well, the derivative of a constant is 0, right? So these are going to be any values of y that make y prime equal to 0. That's what I want to look for, okay? There are 3 types of equilibrium solutions. If you go to the second page of the handout, the wording on this is going to scare you, but I'm going to help you with it, okay? The first type are when they are stable. It is stable if y at a point near it is approaching the constant as I get really far to the right side. So the solutions are approaching my constant. So what this means for the slope field, grabbing a pen, what this means for the slope field, so if y is equal to a constant, then my lines are going to be just straight lines because it's a constant. It's that on either side, I'm approaching it. So above it, I'm pointing down. Below it, I'm pointing up. That's when it's stable. We also have unstable. And what this means is it never approaches my constant as I go really far to the right. So what this means, again, if it's a constant, my lines are going to be just straight, flat lines. Unstable means above it, I'm pointing up. Below it, I'm pointing down. I'm not pointing towards it, is what I mean. And then our third type is semi-stable, which means it's neither one of these things. Which basically means, again, it's going to be a straight line. One side is pointing towards it, and one side is not. It doesn't matter which one is which, though. So like here, they are both towards it. Here, they are both away. This is one of each, is what it means. So what I'm going to do is I'm going to find what my equilibrium solutions are by setting the derivative equal to 0 and then solving it for the y. After that, I can draw my slope field and see what's happening. Okay, so that's what I want to do. Example number 3, create a direction field for the differential equation y prime equals y minus 3 squared times y squared plus y minus 2, and I did identify any equilibrium solutions and then classify them as one of these 3 things. I'm actually not going to do example 3 the way that they have it written here. I'm going to first find what they are. So first I'm going to find the equilibriums. Then after that, draw the slope field, because then I won't have to draw the whole thing. I can just draw the points that I need, right? Then use that to classify it. So let's do that. Example number 3. The differential equation was y prime equals y minus 3 squared times y squared plus y minus 2. So remember, the equilibrium solutions are where y is equal to a constant, right? Well, if y is equal to a constant, that means y prime is equal to 0. So what I want to do is set this equal to 0 and solve it for the y. This looks hard, but it's actually not. The factors are already here, so I'm going to set each factor equal to 0, which is easy here. Add 3, you get y equals 3. Easy enough. For this one, I can factor that. I need the factors of negative 2, whose sum is equal to positive 1. That's y plus 2, y minus 1. Set both of those equal to 0. Y equals negative 2, and y equals 1. So the equilibrium solutions are, the one furthest down is y equals negative 2. Then I have y equals 1, and I have y is equal to 3. So now I've got to use my slope field to classify these as stable, not stable, or semi-stable. So let's draw our slope field. What was really helpful about solving it before I draw this is that now I don't have to draw the whole thing. I can just draw what I need, right? So I start at y is equal to negative 2. I know everything here is a straight line. Why? Because of this right here. Straight line. Also at y equals 1. And then y equals 3. So now instead of needing to draw the whole thing, I can just look at above and below those straight lines. So for example, below this one would be y is equal to negative 3. Now notice what's really nice is my y prime only has the y's in here. So it doesn't matter what I have for x, my y's are all that I need. So here y is equal to negative 3. So let's see what happens there. Negative 3 minus 3 squared. I factored this so I can use the factors. Negative 3 plus 2, negative 3 minus 1. Negative 3 minus 3 is negative 6. Square that is 36. Negative 3 plus 2 is negative 1. Negative 3 minus 1 is negative 4. 36 times negative 1 is negative 36. Negative 36 times negative 4 is going to be 144, which means these are pointing upwards. It's positive, so they're pointing up. Now above it is y equals -1. So -1 minus 3 squared times -1 plus 2 times -1 minus 1. That's going to be -4 squared, which is 16. -1 plus 2 is 1. -1 minus 1 is -2. 16 times 1 is 16 times -2 is -32. So these are pointing down. I also need below this line, which is at y equals 0. 0 minus 3 squared. 0 plus 2, 0 minus 1. -3 squared is 9. 0 plus 2 is 2. 0 minus 1 is -1. 9 times 2 is 18 times the -1 is -18. So at 0, they're pointing down. I also need above it. This would be y equals 2. I'm getting another board, sorry. We're out of room. Be y equals 2. 2 minus 3 squared. 2 plus 2. 2 minus 1. 2 minus 3 is -1. Square that, you get 1. 2 plus 2 is 4. 2 minus 1 is 1. 1 times 4 times 1 is 4. So at y equals 2, they're pointing up. And then lastly, I need above 3, which is going to be y equals 4. 4 minus 3 squared times 4 plus 2 times 4 minus 1. 4 minus 3 squared is 1. 1 squared is 1. 4 plus 2 is 6. 4 minus 1 is 3. 1 times 6 times 3 is 18. So at y equals 4, they're also pointing up. So now I can classify all three of these things. So at y equals the -2, -2 is right here. Above it and below it, I'm pointing towards it, right? So I'm going towards this y, towards it, towards it, towards it, towards it. That means y equals the -2 is stable. For 1 is right here. Above it and below it, I'm pointing away. I'm pointing away here, I'm pointing away and away and away. So this is unstable. At y equals 3, right here, above it, I'm pointing up. Below it, I'm pointing up. So it's half and half, right? That makes it semi-stable. Remember, if any of that doesn't make sense, just let me know. I'll be happy to help out. But that's how I classify these things. The last example is example number 4. It's the same thing, but this time it's going to be y prime is equal to x plus 5 times y plus 2 times y squared minus 4y plus 4. But we're going to do the same thing. So again, this time it is y prime equals x plus 5 times y plus 2 times y squared minus 4y plus 4. Okay, remember, I'm looking for everywhere where y is a constant, right? Which we said means y prime is equal to 0. Notice I'm looking for the y's. So even though x is here, I don't care about that, right? I only care about what's happening with the y's, okay? So when I set this equal to 0, I'm only worrying about the y's. So y plus 2 is 0. Y squared minus 4y plus 4 is 0. Subtract 2, you get y equals -2. Right here, I need the factors of 4 whose sum is equal to -4. That's going to be -2 and -2, which you can write as y minus 2 squared. So set y minus 2 equal to 0, and you get 2. So for this one, the equilibrium solutions are y equals -2 and y equals 2. So let's go ahead and draw our slope field. Remember, the idea is that I'm looking at as I go really far to the right, okay? As x gets really big, this term's always going to be positive. Meaning, when I plug in stuff, I don't, for the purposes of what I'm trying to do here, I don't really need this because it's always going to be positive as I go really far to the right side. So I don't have to really worry about this, okay? So just a heads up there. So -2 is my first one, and +2 is my second one. Both going to be straight lines. So I need below the -2, which is going to be -3. You get -3 plus 2, and we factored this to be y minus 2 squared. So -3 minus 2 squared. -3 plus 2 is -1. -3 minus 2 is -5. Square that, you get 25. So I get -25, and I'm pointing down below it. Above it, it's going to be y equals -1. So that's going to be -1 plus 2. Whoa. -1 plus 2 times -1 minus 2 squared. -1 plus 2 is 1. -1 minus 2 is -3. Square it, you get 9. So +9 means I'm pointing up. Below this one is below 2 is 1. So y equals 1. 1 plus 2, 1 minus 2 squared. 1 plus 2 is 3. 1 minus 2, square that, it's going to be +1, which gives you 3. So I'm pointing up. Above 2 is going to be 3. So 3 plus 2 times 3 minus 2 squared. 3 plus 2 is 5. 3 minus 2 is 1. 1 squared is 1. So you get +5. So looking here at the -2, they are not pointing towards it, right? So that's going to be unstable. At y equals 2, one is pointing towards it, but the other one is not. So that's going to be semi-stable. So again, if any of that doesn't make sense, let me know. I will be happy to help you out.